Hello and welcome. This is Pam. Today, the topic is rethinking multiple sclerosis. Could MS be a vascular disorder caused by parasites? If we haven't met, my name is Pam Bartha, and I'm the author of Become a Wellness Champion and the founder of Live Disease Free. This topic is very near and dear to my heart because I'm on a mission to find the real root cause of multiple sclerosis. And I have shared a mountain of evidence, various different types of parasites that are linked to multiple sclerosis, why it's not just one parasite. We've talked a lot about that. But what's really exciting, we haven't seen a lot of movement in the research of multiple sclerosis for decades. We've been stuck in this paradigm of autoimmune disease. It's autoimmune disease, and we need to have better, newer, different types of immunosuppressive drugs to control the immune system because it's attacking our nerves for no apparent reason. Well, there is a large body of evidence that is growing that shows that multiple sclerosis is a vascular disorder. And they're seeing significant abnormalities in multiple sclerosis with respect to our cardiovascular system. And we're going to talk about that. And then, of course, we want to know, well, why? Why is that the case? Why is there an issue with our blood vessels? And we'll talk about that also, because there's always a root cause. And there is a lot of evidence showing that there are certain types of parasites, one in particular, that could be heavily involved with this. But if you follow my work, you know that I've always shared that multiple sclerosis is not caused by one type of parasites. It's caused by multiple. Think about it as if you have a garden. You will never, if you're managing weeds, you'll never have just one type of weed in your garden. You're going to have multiple weeds. And so when you have multiple weeds, then it's just the same thing inside of us. We have different types of worms. We have different types of protozoa, bacteria, fungi, but some of them are bigger culprits than others. We have been stuck in this paradigm of MS as an autoimmune disease, and our immune system is attacking our nerve tissue for no apparent reason. They don't know why. We have inflammation. We have these lesions in the central nervous system. They say that our immune cells are involved, but they don't know why. And so what if this is not true? What if we are completely off track? What if it's a whole different situation that we're dealing with? And that is what it looks like. It's important to know that this autoimmune theory with multiple sclerosis, it has never been proven. I just revisited a video again of 3, I'm sure they're neurologists, and they were discussing, this was maybe 5 years ago, and they were discussing how we can't call MS an autoimmune disorder because we've never found an autoantigen, meaning they've never found a protein or a molecule in our body that the immune system is actually attacking. It's a theory that has never been proven, and they've never found an autoantigen to prove it. So it is true that the immune system is active. Yes, absolutely. The immune system is fighting something. What is the primary job of the immune system? To defend us from invaders, to protect us from infections, from different parasites. And so what if the immune system is just doing its job? And this vascular disorder, what if that is just the result of immune activation of our immune system attacking some kind of parasitic infection? So this is really huge. With every lesion, I would say all of them or the vast majority of them, it's been recognized now by the 2024 McDonald criteria, right? That's really huge. So with every lesion, they're seeing that it is formed around a blood vessel. So the lesions that cause or that are associated with multiple sclerosis that are found in the brain, in the central nervous system, there's always a blood vessel that runs through them, right? And that is a hallmark sign. It's really, really significant. And finally, the expert panel that decides how we diagnose and treat MS, they finally have acknowledged that. That is really huge. So this has led a lot of researchers to kind of look into okay, so if there's a blood vessel going through every lesion, and that's where the the lesion is centered around the blood vessel, then could MS be a vascular disorder? There is different research that has looked at this, and they have found that in MS, multiple sclerosis, we have endothelial dysfunction, meaning that the blood vessels are not working properly in our brain. And we also have, I've talked about this before, they found that we have leaky blood-brain barrier, and there is a disruption in the blood-brain barrier. There's altered blood flow. We know that through the work of, I think it's Dr. Zamboni with CCSVI in the past. And so when there are these changes in our blood flow, it is going to impact nutrients, it's going to impact oxygen. And if the blood flow is obstructed, if we get an obstruction, and we can have so much damage from various reasons, we can have damage, whether it's other factors, but for sure this parasite we're going to talk about will cause definite damage to the blood vessel lining and will cause this, it can cause even a microbleed. Vascular dysfunction is measurable in imaging and lab studies, and that happens long before they've seen this, like these changes in our blood vessels well before symptoms for multiple sclerosis appear. And so they're saying that this faulty blood vessels, for whatever reason, and that is really causing the lesions. And of course, then the immune system is going to move in. The response of the immune system is after the vascular dysfunction. So it's not that the immune system is just there attacking our nerve tissue for no reason. It's just bored, off, gone haywire, and it's just attacking our myelin. No, they're saying that the vascular disorder happens first, and then there could be compromised, like either broken blood vessels or other ways that the blood-brain barrier becomes leaky. Then things leak into our brain that shouldn't be there. And then the immune system is like, oh my gosh, I have to clean up this mess. We have to clean up we can't have this in the brain. That's what the immune system's job is to really keep certain things in the brain and allow certain things in and allow certain things not to go into the brain. This blood-brain barrier, the leaky blood-brain barrier, we've talked about that before. You can even just type "live disease-free" in Google and blood-brain barrier and multiple sclerosis, and you'll find the talk that I did there. Because I have a huge library in my blog post. So if you want to find things fast, just type in "live disease-free" in the topic and you'll find the posts. It'll show up a lot quicker that way. So think about like our blood vessels. They're almost like an irrigation system in our brain. And so it's kind of like they're like hoses, and but they're like leaky hoses, and they're bringing specific nutrients and oxygen to our brain, and they're carrying waste away. And if there's damage to these hoses, then it becomes a leaky blood-brain barrier. So there's literally just cells that form this blood-brain barrier, and they're held tightly together, so they will only let certain things go in and out. And then when there's damage to these blood vessels, then we end up with things spilling. It's like the hoses from our irrigation system are springing a leak, and then we have material from our blood going into our brain that shouldn't go in. So there will be red blood cells, there will be different immune cells, there will be waste material. And in our blood, we could have infections, we could have, small numbers of pathogens, parasites, whatever, and all of that can spill into our brain. And then our immune system is going to go to work to clean that up. That's its job, is to keep the brain alive. So it's doing its job. So blood will move into the brain then, and immune cells will move in. Oxygen, of course, is not going to be delivered properly. Nutrients may not be delivered properly. And we can end up with inflammation, right? Because inflammation is the war where the immune system is fighting some type of enemy. And if our red blood cells are in our blood vessels, in the irrigation hoses, it's fine. But when they're just floating around in the brain, the immune system has to protect us from that. It has to clean it up. MRI technology now shows this central vein in the core of the vast majority of all MS lesions. That's really, really significant. So nearly every lesion has a damaged vein in its center. And so studies also show that these rings of iron around the outside edge of a lesion. So you'll have a lesion that springs out around a blood vessel, and then around the outer edge of that lesion, there is this ring of iron. And we know that red blood cells carry iron, hemoglobin. And so when the immune system is cleaning up, we can have a deposit of iron remaining from the red blood cells that ended up in the lesion in that area. So this has been known for many, many years about those rings of iron, probably like the early 1900s in multiple sclerosis. Also, the vascular risk connection, so large population studies in various countries like England, Denmark, and Sweden, they found that people diagnosed with MS have 150 to 300% higher risk of heart disease, stroke, and death. So huge increase, 150 to 300% increased risk of heart disease and stroke and death. When they saw that significantly higher cardiovascular disease in MS, they were taking into account things like lifestyle, smoking, diabetes, medication. So they were controlling for those factors. And they still found that with MS, 150 to 300% higher risk of having these different heart disease and stroke and death from it. MS also shows striking overlap with hypertension, diabetes, and obesity, which are all classic cardiovascular disorders also. We always want to look for a cure, right? We don't want to just go, okay, now we have before it was faulty immune cells that we have to suppress, we have to destroy them, we have to take drugs for the rest of our lives. And now, our vascular system, the blood vessels are not working properly. So what kind of drugs could we take to try to make them work properly, right? It's just like it doesn't end. Or we could say, what is causing our blood vessels to be dysfunctional, leaky, right? Why are we having a leaky blood-brain barrier? What's different? What is causing this? What is the root cause? That is what we want, because we want to treat the root cause. We want to recover, and we want to heal, and we want to live our very best life. So I'm not saying that malaria, Babesia, or a similar protozoa is the only cause of all of our neurological symptoms in multiple sclerosis, but I am saying there is a mountain of evidence that this is one of the very big players in multiple sclerosis. So last week, make sure to go back and look at that video if you haven't seen it, or even our blog post is better because you can see my notes. You can scan the notes or watch the shorter version of the video. And you can find that on livediseasefree.com, livediseasefree.com. Go to blog and you'll see the most recent post. I'll be posting this research. It'll be either Friday or Monday. It'll be published, and that'll be a new blog post. So every week I'm releasing this new research, and some of it's not new, but it's just newly rediscovered. The link between malaria and MS dates back to the late 1800s, early 1900s, where they actually had malaria in the United States. They were treating people that had malaria. They were treating them with a malaria drug, quinine, and they were noticing that when they were treating people for malaria, that the people that had MS that were getting the malaria drug, they had significant improvements in their health, like really significant. And they were like, that's really strange. And so then there were some researchers that started to carry on with that research, and they started to look for malaria in multiple sclerosis, and they looked for antibodies to malaria in multiple sclerosis. They found malaria and antibodies to malaria in multiple sclerosis patients and not in healthy controls. And they also found that it's really hard to find malaria in the brains of people. So if they're finding it, that was pretty significant because it was hard to find in anybody. And so there's at least 140 years of research linking multiple sclerosis to some type of a Babesia, malaria type of protozoa. 140 years of research. So that's 75 peer-reviewed scientific articles linking MS to malaria or a protozoa similar to malaria. So in 30 to 40% of MS patients, they detected malaria antibodies. And in 20% of MS patients, they detected the actual parasites, malaria parasites. And in 0% of the patients that had other diseases or they were healthy people, they could not find the parasite, the malaria parasite in them. So that is really huge. And another big thing is that the people that had multiple sclerosis, when they found the malaria parasite in them, none of them had traveled to tropical destinations. They got them in their own country, whether it was the United States, Canada. I think these studies were mostly done in the United States. And then also some of the doctors went on to start treating malaria with quinine, which is a malaria drug, and had tremendous recoveries in multiple sclerosis patients. And also, and I should say all that information, the research was dropped. So there was like heavily researched field of, all this like, oh my gosh, like we're finding malaria in MS, we're finding antibodies to malaria in multiple sclerosis, we're treating MS patients with quinine and they're doing so well. And in healthy people, they don't have the antibodies, they don't have the malaria, the parasite. So like all that research got lost. It got dropped. It was forgotten for decades. And all of this happened around the 1950s and 1960s, where before that, researchers really believed that all diseases were caused by infections. And then all of a sudden, we just stepped into this whole autoimmune theory in the 1950s or 60s. There was a very wealthy family group that started to really influence the doctors, the medical schools. And from that point on, everything is autoimmune, including, all the different types of conditions, not just multiple sclerosis. There are other similarities in pathology with multiple sclerosis and malaria. So some of them would be, so this might be a little technical for you, but for some of you that are research buffs, so granulomas and capillary hemorrhages. So we talked about that, where little blood vessels in the brain break. Iron deposits, we talked about that. And leptomeningitis. Also, people that are suffering from cerebral malaria and multiple sclerosis, they all have lesions found in the same areas of the brain. So if you have cerebral malaria, you have lesions, and they will be located in the same area of the brain as the MS lesions. So there's a lot of similarities. Now let's talk about symptoms. The symptoms of malaria are virtually identical to symptoms of MS. So I've talked about several different types of infections that were found in the central nervous system of MS, and a lot of them cause similar symptoms. And that would make sense, because if you have these parasites, these infections up against certain nerves, and the immune system is fighting them, and those nerves are becoming inflamed, you would have similar symptoms. So it's not a stretch to say, well, Pam, you said that worms cause, the filarial worms cause these symptoms, and Borrelia causes these symptoms. Yeah, they do. In the scientific literature, they do. But it's like, which parasites do you have? Which nerves, where are they located? Which nerves are being inflamed? Because there's a war beside those nerves. So with respect to cerebral malaria and multiple sclerosis, these are some common symptoms, not exhaustive, but some common symptoms. So muscle aches, spasms, fatigue, pain, weakness, balance issues, dizziness, vision problems, optic neuritis is included, hearing loss, tinnitus, and paralysis. So those are really common symptoms in multiple sclerosis and in cerebral malaria, meaning when malaria enters the central nervous system and causes lesions. Then in 2021, the University of Calgary published a study, and in that study, they looked at 35 patients that had primary progressive multiple sclerosis, and they gave them hydroxychloroquine. And they would have expected, like normally with primary progressive, they would have seen a decline over 18 months in 14 of the patients. That would have been pretty typical. But The patients that received hydroxychloroquine, they only had a decline or an advancement of progression in only 8 of the patients. So instead of 14, 8, that's almost like half. So this anti-malaria drug, hydroxychloroquine, it significantly reduced progression in primary progressive multiple sclerosis, which is a type of MS where they really don't have treatment for. Like none of the treatments are effective, but they just admit they don't have really anything for it. They are starting to use 1 or 2 drugs now. Again, just they're depleting B cells. It is just a crying shame what they're doing. And then in the 2010, somewhere like 2010, 2013, Dr. Fry from Fry Laboratories, he discovered a specific protozoa that is found in multiple sclerosis patients. He gave it a different name because he said it doesn't look exactly like malaria or like Babesia, so he gave it a different name. And so that's Dr. Fry from Fry Laboratories. And he found a new malaria-like protozoa in multiple sclerosis patients. And then also the University of Calgary, that was a really big one, right? Giving MS patients the hydroxychloroquine and noticing, especially primary progressive, which doesn't let up. You don't get the breaks, you don't get the recovery. It's just a continual decline. So like if there is no MS drug that gives that type of results, why aren't they giving multiple sclerosis patients or even testing, trying to see if it helps them? Because it's so cheap probably, and it's not really profitable. So when this protozoa infects red blood cells, they become sticky, they're dysfunctional. They stick to the lining, the blood vessel lining. They can also stick to each other. They can form clumps. They can obstruct blood vessels, so they can cause ruptures, right? The blocked flow and ruptures. We see in multiple sclerosis, what is true is that we have poor veinage, like the veins, they're not draining properly, and we see iron deposits. And with malaria Babesia, the similarity there is that the red blood cells they know that they adhere to the walls of the blood vessels and they block the flow. So the lining of the blood vessels are inflamed in malaria and in multiple sclerosis. And also anemia is common in both malaria and multiple sclerosis. Or when I say malaria, remember, it's just a protozoa that could be malaria, but it could be, like, we're not looking for it. So unfortunately, we don't know which species it is. Also platelet activation. It triggers microclots in malaria. There is elevated platelet activity in multiple sclerosis. And then also red blood cell stiffness. So red blood cells are supposed to be able to kind of fold on themselves because they have to squish into these tiny little capillaries in the brain. They have to be able to bend and move and become deformed to fit through small blood vessels. In malaria, they're not. So there's a loss of deformability in malaria. So they are rigid and they're sick and they're sticky. They don't function properly. And this has also been reported in MS blood tests, is the red blood cell stiffness. So this is all more evidence that multiple sclerosis is a vascular disorder. Hypoxia, so that means lack of oxygen. That is a core feature in malaria, and it's also present in all lesions in multiple sclerosis. So why protozoa fits the picture so well? Because we know that these single cell protists that are like Babesia or malaria, they are intraerythrocytic parasites, meaning that they infect our red blood cells, and they also cause vascular blockage and microbleeds, which really matches what we see in multiple sclerosis. They do suppress immune cell activity. The immune system is just doing its job. And I've even shared, which is a different parasites, because remember I've shared there's different parasites, but with Borrelia, it's been shown that Borrelia can infect the myelin. So that's just one parasite. And we know that if you have infected red blood cells, that they are going to get into the central nervous system. And it's been shown, as I shared before, that they found malaria in the central nervous system of MS. So this whole link between parasites and multiple sclerosis. I've shared a ton of research. Just go to our blog post on livediseasefree.com, livediseasefree.com, and you'll see many, many studies and many articles that I've written on this. But things, and I've even talked about this, like levomizole, which is a roundworm medication, and it's been really shown to dramatically decrease relapses in multiple sclerosis. So if it's autoimmune, how can a parasite drug, and why is it that these parasite drugs really help multiple sclerosis? What is their primary focus? And then the study I shared with you about hydroxychloroquine, the 2021 study, where they gave primary progressive multiple sclerosis patients the hydroxychloroquine, and they noticed a significant decrease in progression. That's really exciting. Why was that not further studied? Why didn't they try to disprove it? Why didn't they try to prove it or disprove it? Why are they not interested in looking for parasites? This endothelial stability and also immune activation definitely would be caused by parasites. Parasitic infections would do that. So looking for the root cause, like, is multiple sclerosis part of it or all of it? Is it a vascular infection? It could be malaria, it could be Babesia, it could be a different one where this parasite enters our bloodstream. And like, we might say, well, why are we susceptible to this? Because probably other people have been exposed also and they did not get multiple sclerosis. Well, for myself, I can just speak for myself, and what I see in my students is that many of us have had dysbiosis, where our microbes are out of balance for years before we have multiple sclerosis. We've had gut issues. We've been on a lot of antibiotics. We might have had gas, constipation, diarrhea, stomach pain, right? And then all other things that come with it, sleep disturbances, mood swings, foggy head, poor memory. All of those things happen before we have multiple sclerosis. And I've even shared a study where they found that 5 years before multiple sclerosis, a lot of people that went on to develop multiple sclerosis, 5 years before their diagnosis, they had a lot of gut issues, a lot of gut symptoms. When we're really out of balance and we are, let's say, infected with this protozoa, it could be through a biting insect like a mosquito or a tick or other, then what'll happen is that our immune system might not clear it. And then it ends up living in our blood, infecting our red blood cells. And maybe there are circumstances in our life, like maybe we're under high stress, we're not getting enough sleep, maybe we're eating too many carbs, eating, a lot of processed high sugar. So we're not living the healthiest lifestyle. And we've got this time bomb going inside of us. And so then more and more of our red blood cells become sticky, and they start to clump. They get stuck onto the blood vessel walls. They start to build up and make these clusters of sticky, dysfunctional red blood cells, which is really going to affect our oxygen, right? Because as our red blood cells definitely bring oxygen to all parts of our body. And then when the red blood cells are supposed to go through these tiny little capillaries in our brain and in other parts of the body, they are not able to fold and to kind of squish themselves to get in through those vessels, and they're stiff and they're rigid, and they can actually cause blockages. When we have blockages, we can have disruption, damage to the lining of those vessels. Then we have leaky blood-brain barrier. And then all of a sudden, things that are in our blood will spill into our brain. And then we have this lesion forming, and that's a pocket of inflammation where the immune system is trying to do damage control, because the immune system gets called into that area by other things. Like, I think there's proteins in the blood vessel lining that if the blood vessel lining is damaged, then it sends signals. Our body is so intelligently designed, like that we would think that we should be destroying our immune cells is absolute insanity. We have a spillage into the blood, into our brain. The immune system is trying to clean it up. That is the war. The inflammation is the immune system is fighting something, invaders. So the red blood cells, the immune cells, the parasites that get in there, the waste material, all of that stuff should not be in the brain, and the immune cells are going to clean up and kill what they need to, destroy, remove. We end up with a lesion, and then we end up with a remnant of iron from the red blood cells that spilled into the lesion. around the periphery of the lesion. So that is so simple. Like, let's start to study this, right? Prove this theory wrong. Why won't we look at this? It's very, very plausible with over 140 years of research linking a protozoa with multiple sclerosis. And then all of this evidence more recently about how MS is a vascular disorder. And then even the 2024 McDonald criteria saying, oh yes, there is a blood vessel in the center of every lesion. Like, duh, that's how they're diagnosing MS. So could the lesions be coming from the blood vessels? Yes, I would think so. Why won't we study that? So this has huge implications for diagnosis, because when people start getting the symptoms, the neurological symptoms, we could start looking. We could start looking to see, like, do they have healthy cardiovascular system? We could start looking for parasites like protozoa, like malaria type protozoa. We could be looking at their blood work. We could say, like, are there changes in their red blood cells? Are there less red blood cells? Are they wider than normal? Do we see anemia? Do we see that the red blood cells are sticky, that they are deformed? Do we see changes in our platelets? It's so simple. They're doing the blood work anyhow. And so this is really where we want to come in and help bring change. We want to help bring better diagnostic tools for doctors to be able to recognize these things early. So maybe when we have our first flare, it's like, oh, let's look at your blood. Let's look at your red blood cells, and let's look at your platelets, and let's look for parasites, and on. And it's more difficult to look for chronic parasites, especially in the brain. But we could start with symptoms, and we can start with looking at blood work, and that can really get us onto the bandwagon of going in the right direction. And then what is the harm if you have symptoms of malaria, like the same symptoms, and you have evidence of this protozoa? Then they give hydroxychloroquine to lupus patients, to arthritis patients. It's not a cure. Obviously, they're not treating the parasites 100%. They're managing them. But wouldn't that be more helpful if it did manage it better than the immunosuppressive drugs, which don't help, because the immune system is just doing its job? This way, we could catch multiple sclerosis and other chronic diseases earlier. We could help people to recover quickly, have minimal damage. Maybe they'd have one attack, which they could recover from, and they can get on with their life. And we could save our healthcare system. Our healthcare system would not be so bogged down with these astronomical costs, which we can afford. They're not sustainable. We cannot afford them. So that would really prevent a lot of pain and agony, and it would prevent a lot of disability and people not living their life and people dying prematurely. So treating protozoa would be a very simple thing to do. Of course, we can definitely look at symptoms. We can look at blood work. And so that would definitely, of course, we have to do a healthy lifestyle. All of those things are important. And, these doctors, hopefully, as we start to share this information, they'll see that it's not just the malaria. We want to correct our microbiome enough so that when we get that next bite from the mosquito or from a tick or from another biting insect, it could be a horsefly, it could be those biting flies, any biting insect, spiders, that we're not going to just crash and burn because our microbiome is in balance enough, then our immune system will be strong enough. Most of our immune system is around our digestive tract, around our intestines. Probably about 80% or more of our immune system is located around our intestines, because that is the greatest abundant population of microbes that live in our body. So yes, some are in our mouth and our nose and our throat and parts of our urinary tract and our reproductive tract, but mostly it's in the gut. And so when our microbes are in balance, then our immune system is not under so much stress, and it's able to deal with when we get other pathogens that sneak into us. We don't want to live on drugs. We just want to be healthy. It is possible. People are recovering all the time. So this whole new perspective for multiple sclerosis is that Looking at the old paradigm, multiple sclerosis is an autoimmune disease. The new view is that, multiple sclerosis is actually a vascular disorder. There's actually damage to the blood vessels that, not just in the brain, but also the blood vessels in the brain, and that's causing a leaky blood-brain barrier. And of course, the immune cells are going to be called in, and of course, they're going to do cleanup. And we do have inflammation because of that damage. So let's look for the cause of why we are having this vascular issue, why we are having dysfunction in our blood vessels, in our red blood cells, right? That's also important because that really helps us to understand that there is a reason, that it is not autoimmune. They've never found the autoantigen. That has never been found. So it's not proven that autoimmune is what causes multiple sclerosis. So this really matters because we can, number one, prevent this, we can reverse it quickly, we can recover quickly, and we can save billions and hundreds of billions of dollars, if not trillions of dollars by now. So maybe you're somebody who's new to all of this. Make sure to watch the successes we have on our YouTube playlist, Live Disease Free playlist. I've got lots of videos on YouTube on Live Disease Free channel. But if you want to just scan my notes really quickly, then go to livediseasefree.com to the blog and look at just the topics, and you'll be like, pick and choose the topics that you want to scan my notes, or you can watch the shortened video. Then also, when you get to that place where you're like, okay, I'm a believer, I know that I'm dealing with parasites, I need help, I need support, I don't have a practitioner that can help me, I'm ready. I want these critters out of me as quickly as possible. You will get to that place if you start researching. So start there. And when you're ready, then watch my masterclass training. And after you've watched it, you can book a time to chat with me to make sure it's a good fit. And I would be honored to serve you. We have students joining our program every week, and I help you to get ready to treat, make sure you're feeling better, make the parasites more quiet, opening up detox pathways. This is truly the most cost-effective way to recover because you are doing most of the work yourself. You don't need a ton of supplements. You don't need a lot of testing. It's just very minimal because you want to get ready to treat and treat as quickly as possible. But it does take strategy. These parasites, it's not like if you have strep throat and you take an antibiotic and you're good in 10 days. That's not how it is with worms and protozoa and bacteria that's chronically like in your central nervous system and just deep in your body. And the worms can lay 200,000 eggs in a day, so they're just really difficult to treat. So I'd be honored to support you. And if you enjoy this research, I'm really trying hard to bring awareness. I'm spending hours and hours studying, and I have for many years. I'm on a mission to help bring this research to the forefront. You can help me by sharing this with groups. I have some people that are wellness champions that are just sharing with everybody. So help us get the word out. Like, share, and subscribe. That helps others to see this research and start talking about it. Start talking about it in different groups. Share the link, share the research. I also created a one-page PDF that you can take to a healthcare professional that is open. Don't take it to somebody who's going to be really negative and nasty to you, but somebody who's really open. You can just look for Live Disease Free in Google and then put down MS is infectious disease, and you'll find that PDF and put PDF behind it, and it'll pull it up quickly. And then that way you can actually share that. You can email your doctor. It has all the links. He can further study it. And next week, I'm going to be talking about how many different parasites are known to cause lesions in the central nervous system. So they're like, we don't know what's causing these lesions. Well, science says that parasites cause lesions in the central nervous system. It's not rocket science. It's not a mystery. And this is yet more evidence that we have to get out. So I'm going to keep preaching this research, sharing it, and you guys can help me. Together we can bring change. If you need support, make sure to reach out and be honored to support you. With that, I hope you have a wonderful week. Talk to you next week. Take care and bye-bye for now.